Good morning, friends, and welcome to another class. In today's class, we would continue with naming of compounds. I will focus on how to name compounds that contain oxo-anions. We already have looked at how to name oxo-anions, so I would expect us to differentiate between oxo-anions from compounds that contain oxo-anions. So this is an oxo-anion, CO3 minus 2, it's an oxo-anion. Now this CO3 minus 2 called carbonate can be combined with another element, let's say a cation, sodium, and when the two substances join together, they will form sodium 2CO3. This sodium CO3 is what we call a compound of oxo-anion because it contains a cation, which is the sodium, and an oxo-anion. So it's a compound, but it contains an oxo-anion with something else there. Remember, it could also be the cation here. In this case, the cation is a single element sodium, but there are actually instances where the cation could also be a complex ion. For example, you can have, let's look at this one. You can have this cation, ammonia, ammonium. This is also a cation, but it's a complex cation that can also be combined with, let's say, CO3 minus 2. Then the two will join together to form NH, all into brackets 2CO3. Well, this sounds a little complex, so we will not really focus on these kinds of compounds. We will focus on the simplest forms of compounds, the one we looked at initially. So we look at a single cation combined with an oxo-anion to form a compound of oxo-anion. So that's what compounds of oxo-anions are. Now, so you realize that this compound of oxo-anion contains a cation, this one, it contains the oxo-anion. Now, in naming these kinds of compounds, the easiest way to deal with it is first to name the first part, which is the cation. That's this one. In this case, you name the sodium. When you are done, then you name the oxo-anion separately. Then in between the sodium and the oxo-anion, you put parentheses depending on whether the cation you are dealing with is a cation with variable oxidation numbers or not. And we'll be looking at examples, and I'm sure by the time we finish with those examples, you understand what I'm talking about. So let's look at the first example. So in this example, you have a compound of oxo-anion. This compound contains two main things. It contains potassium and it contains this oxo-anion. So that's potassium part is +1 and the oxo-anion NO3 -1. So the two join together to form this compound. So in naming this compound, you name the potassium separately. When you are done, then you name the oxo-anion. So the name will start with potassium. Then remember, we will bring parentheses depending on whether the potassium has a variable oxidation state or not. You and I know that potassium is an element in group 1, so it has a fixed oxidation state of 1. Its oxidation state is positive 1. So it does not have a variable oxidation state. So we do not need to bring a parenthesis. In other examples, would be looking at when you would be bringing parenthesis. So in this case, you do not need the parenthesis. So we move on straight to the oxo-anion. So we are done with the potassium. For this oxo-anion is a dry oxo. So dry oxo nitrate. I believe you remember how we name oxo-anions. We've done that in previous lessons. So if you've forgotten, I would advise you visit those lessons and read them. So dry oxo nitrate. Then we bring our bracket. Inside this bracket, we are going to write the oxidation state of the nitrogen. So let's calculate the oxidation state of the nitrogen in the oxo-anion. So remember, we have nitrogen plus 3 of the oxygen equals to minus 1. That's the charge on the oxo-anion. So nitrogen plus 3, charge of oxygen is minus 2 equals to minus 1. So that will give us nitrogen minus 6 equals to minus 1. So that will give us nitrogen equals to minus 1 plus 6. So the oxidation state of the nitrogen will be positive 5, which is V. So the parenthesis will have the oxidation number V, which stand for 5. So the name of this compound will be potassium trioxo nitrate 5. Simple as that. Let's look at the next example. So in this next example, we have this compound Cu, which is copper, and SO4. So we can have copper here, which is 2 plus. Then we can have the oxo-anion SO4 minus 2. So what it means that we have to name this copper. When you are done, we name this oxo-anion. So we start with copper. But remember, copper is one of those elements with variable oxidation state. So what it means is that we need to bring our bracket or parenthesis with the oxidation state of the copper. Here in this case, the oxidation state of the copper is a charge on this copper, which is, so we show that. So we are done with the copper. We'd have to move on to the oxo-anion. With the tetra-oxo, so it's tetra-oxo sulfate. So we bring our brackets or parentheses in which we're going to show the oxidation state of the sulfur. So let's calculate the oxidation state of the sulfur. Sulfur plus 4 of the oxygens equals to the charge on the also anion, that's minus 2. Sulfur plus 4, the charge of oxygen is minus 2 equals to minus 2. So that will give us sulfur, that will give us minus 8 equals to minus 2. So this will give us the sulfur equals to minus 2 plus 8. So the oxidation state of the sulfur would give us positive 6, which is Vi. So that's what we're going to write in the parenthesis. So that would be Vi. So the name of this compound would be copper 2 tetraoxosulfate 6. Simple as that. Let's look at the next example. So we have this compound, and this compound has aluminium 3 plus. It also has the oxo-anion PO4 minus 3. So we name the two separately and join the names together. So first, that will give us aluminium. Remember, aluminium is a group 3 element. Actually, group 3 elements have fixed oxidation numbers, which is positive 3. So here in this case, we will not need any parentheses because aluminium has a fixed oxidation number. So we move on to the next item, which is the oxo-anion. It's a tetraoxo. That will be tetraoxo. It's a phosphate. So phosphate, then parenthesis. In the parenthesis, we would have to calculate the oxidation state of the phosphorus in the phosphate. So that will be the phosphorus plus 4 of the oxygen is equals to minus 3. Then phosphorus plus 4 minus 2 equals to minus 3. So that will give us phosphorus minus 8 equals to minus 3. So that will give us phosphorus equals to minus 3 plus 8. So this will give us positive 5, which in Roman numeral will be V. So the bracket or parenthesis will put V there. So the name of this compound will be aluminium tetraoxo phosphate 5. Let's look at another example. So we have sodium here. So plus 1, forgive me, and sulfate SO4 minus 2. We name them separately and join the name together. So the first item will be sodium. And remember, sodium is one of the elements with fixed oxidation number. So what it means is that we do not need the parenthesis. Sodium is in group 1. Group 1 element have oxidation state of positive 1 always. So we don't need any parenthesis. So it's just sodium. Let's move on to the oxo-anion. The oxo-anion will start with the tetraoxo because we have 4 oxygens. So that tetraoxo and the sulfate because of the sulfate. Then we bring our parenthesis in which we're going to write the oxidation state of the sulfur. Let's calculate the oxidation state of our sulfur. That will be sulfur plus 4 of the oxygen equals to the charge on the oxo-anion, which is minus 2. So sulfur plus 4 minus 2, that's the charge of the oxygen, equals to minus 2. That will give us sulfur minus 8 equals to minus 2. So this will give us sulfur equals to minus 2 plus 8, and that will give us equals to positive 6. So the oxidation state of the sulfur in the oxo-anion is positive 6. In Roman numeral format with Vi. So write Vi in the parentheses. So that will be V. So the name of this compound will be sodium tetraoxosulfate. Let's look at another example. So we have zinc joined together with the sulfate. So we name zinc first. So that will be zinc. Remember, zinc is one of the elements with variable oxidation state. So we need to bring our parenthesis and write the oxidation state of our zinc in the here it is positive 2. So that will be 2. Then we are done with zinc. We would have to write the name of the oxo-anion. So that will be trioxo, 3 oxygen. So trioxosulfate 3, or sulfate, then We determine the oxidation state of our sulfur in the triazosulfate. So let's calculate that quickly. That will give us sulfur plus 3 of the oxygens equals the charge on the oxo-anion, which is -2. That will give us sulfur plus 3. Charge of oxygen is -2 equals to -2. So this will give us the sulfur -6. That will give us equals to -2. So the sulfur equals to -2 plus 6, which is equals to +4. So +4 in Roman numeral will be 1V, IV, will be IV. So the name of this compound will be zinc 2 trioxosulfate 4. Let's move on to, I believe, the final example. In this final example, we have copper 2 plus, sorry, this copper 1 plus, then SO4 -2. We name them separately. So here, that will be the first item is copper, then its oxidation state. Remember, copper is one of the elements with variable oxidation state. Its oxidation state is this item. We'll put I there, that's +1. Then we name the oxo-anion. So that will be a tetra oxo-sulfate with a parenthesis in which we are going to write the name of the, so sorry, we will be writing the oxidation number of the sulfur. So let's calculate that quickly. We have sulfur plus 4 of the oxygens equals to -2. So that will give us sulfur plus 4 of the -2, which is the charge of the oxygen equals to -2. We have sulfur -8 equals to -1. So we have sulfur equals to -1, then +8. So that will give us +7. So that will give us sulfur. Oxidation state of sulfur will give us VII, the Roman numeral for 7. So we write VII here. So that's the name of the compound. It's copper 1 tetraoxosulfate 7. Simple as that. So, okay, let me just, I think there is a mistake with my calculation. Let me quickly correct that. It's supposed to be 6. Let me quickly, so here is supposed to be 2. Here is 2. So here is 2. So that will be 6. So the name of the compound will be, so this will be 6. Thank you very much. So that will be the name. So this is not 7. It should be 6. So that will be VI. So the name of the compound will be copper 1 tetraoxosulfate 6. As simple as that. And I believe that will be bringing us to the end of today's lesson. Thank you very much. Those of you who have not subscribed to the channel, please subscribe and try and share the videos with your friends, so it would help those who are struggling with integrated science. I'll see you. Take good care of yourselves. Bye.